So my dear learners, welcome today, and we are going to look at linear inequalities. And linear inequalities refer to a statement that is connected by the following symbols. And actually in this particular topic, we are going to remind ourselves of the following symbols. So the following symbols will be very important. This symbol refers to as greater than, and the other symbol is less than. And we have a symbol that includes an equal sign. And in that case, if it is greater than, we say greater than or equal to. Then the other symbol is less than or equal to. Once you understand these symbols, in which case it will connect some statement, therefore we refer to it as inequalities. The first part we are going to look at symbol statements, and in symbol statements I want us to consider a statement like x is equal to 4. And also consider another statement whereby x is greater than 4. And another statement, x is less than 4. Let us look at the three statements. The first one gives a specific number that x is equal to 4. So for this one, it gives a specific number or a specific value. The second statement is x is greater than 4. It simply means that x does not have a specific value, but it takes value which is greater than 4. Take an example: 5, 6, 7, 8, 9, and so on. This number 4 should be less than x. So x can take all of these numbers. The other statement is x is less than 4. For this statement or this inequality, x will take all values that are less than 4 but not equal to 4. That is, numbers which are less than 4, we have 3, 2, 1, 0, -1, and so on, from the number line going to the left or backwards. So that's a symbol statement. The same statement can also be illustrated on a number line. Consider this statement: x is greater than 4. If I draw a number line here, then indicate all values have 0, 1, 2, 3, 4, 5, 6, 7, 8 continuously. Then x is greater than 4. So at 4, we are going to draw an empty circle or unshaded circle. And since x take all values greater than 4, that is 5, 6, 7, 8, then we draw a thick line towards the right with an arrow to show that x will take all values to the right of 4. The arrow shows that the values of x are continuous or endless toward the positive infinity. Then the other one, so for this is x is greater than 4. Then you have x is less than 4. So x is less than 4. So on the number line also we can indicate it. So I have 0, 1, 2, 3, 4, 5, 6, 7. Then since I have the symbol is less than, so 4 is not included. So at 4 I draw a circle, an empty circle or unshaded circle, to show that 4 is not included, is not a value of x. So x will take all values less than 4, that is 3, 2 onwards. So I draw a bold line with an arrow and I label it x is less than 4. That is how you represent the inequality on a number line. Still, we can have other statement that includes the symbol greater than or equals to. So take an example, x is greater than or equals to 0. It simply means that x is equal to 0 and any number that is greater than 0. So illustrating this statement on the number line will be, so I have x is greater than or equal to 0. So at 0, I draw a circle and I shade it because x0 is included. Then I draw a thick line towards the right because x takes all value greater than 0. And that's how we represent this inequality on a number line. Also, let me consider x is less than or equal to 5. Also, this inequality, I can represent it on a number line such that I have, let me draw the number line, minus 1, 0, 1, 2, 3, 4, 5, 6. That is enough. And since 5 is included, is a value, integral value of x, then at 5, I draw a circle and I shade it, meaning that 5 is also a value of x and it takes all values less than 5. So I draw a thick line toward the left. So this is x is less than or equals to 5. So far, we have learned that for these symbols greater than or less than, if you represent it on the number line, we always draw an empty circle to show that the values are not included. And for this symbol greater than or equals to or less than or equals to, we draw a circle which is shaded to show that the value of the unknown or x is included. And also for both of them, you draw a thick line with an arrow to show in which direction the values of x are included. So bearing that in mind, it is very, very important. We move on and we look at compound statements. Sometimes we may be required to represent on a number line all values of x which satisfy two conditions simultaneously. Take an example of these two statements. X is greater than 1 and x is less than or equals to 9. So we need to represent all the values of x which will satisfy these two conditions at the same time. So we needed to combine them into a one compound statement. The first thing which is very important as a learner to consider, 1 and 9, which one is less than the other one? Remember, on the number line, 1 will be to the left, 9 will be to the right. So that simply means for the first inequality, we can also rewrite it as 1 is less than x. Remember, the symbol always point to the lesser number. So this can be written as 1 is less than x, and also x is less than or equals to 9. So this is a compound statement which combines the two inequalities simultaneously. Also, this compound statement can be illustrated on a number line, such that this is the number line. So from -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then from there, considering this inequality, a compound inequality, so 1 is less than x. So we have 1. So 1 is not included, so we draw an empty circle or unshaded circle. And 9 is included, is a value of x since it has an equal sign, less than or equal. So that will be, we draw a circle and we shade it. Then in between we draw a bold line. We draw a bold line such that all these values in between are the solution of the statement. That is, 1 is less than x is less than or equals to 9. So if I consider all the integral values of this compound statement, integral values of x which satisfy this inequality will be 2, 3, 4, 5, 6, 7, 8, and 9. So these are the integral values of x which satisfy the inequality. We can also have another example. We can have this example, that is, x is greater than or equal to -3, and the other statement is x is less than or equal to -1. So from the number line, if you consider -1 and -3, -1 is greater than 3. So -3 will be to the left, -1 will be to the right. So I want to write these two statements such that x will be in between. That is, this can be written as -3 is less than or equal to x. Combined with the second inequality, x is less than or equal to -1. Therefore, this compound statement can be illustrated on a number line, and that is, we have -4. Always try to write a number which is after -3. So we have -4, -3, -2, -1, 0. So in our case here, -3 is included, is a value of x because of the equal sign. So we draw a circle and we shade it. Then the other one, -1, is also a value of x. So we also draw a circle and we shade it. Then in between we draw a bold or a thick line. So this inequality, we have actually represented it on the number line. And all the integral values of this inequality to satisfy the inequality are -3, we have -2 and -1. So next we look at solution of simple inequalities, and in this case let us have this question: solve the inequality x minus 3 is greater than 6. So for this inequality x minus 3 is greater than 6, we are going to add 3 to both sides. If we add 3 to both sides, it will give x is greater than 9. It can be seen that if you substitute any number greater than 9 in the inequality remains true. And in any given inequality, now in our case here, take an example: all values greater than 9, that is 10, 11, 12. If you try to substitute, now x replaced with the 10. 10 is greater than 9, 11 is greater than 9, and so on. Also, we can have another example. So we call this example 1. The other one is example 2. We can have x plus 1 is less than 6. So in this case also we needed to add, that is, we subtract 1 to both sides of the inequality, and we shall end up getting x is less than 5. Therefore, we substitute any value which is less than 5, the inequality will always remain true. So values that are less than 5, that is 4, we have 3, 2, 1 onwards. So replace 4. 4 is less than 5. So the inequality will always remain true. Also, you're going to try another one, that is, solve 2x plus 3 is less than or equal to 5. So the first step we are going to take is to subtract 3 to both sides, that is 2x be less than or equal to, so we subtract, we get 2, then we divide it through by 2, we divide by 2, so x will be less than or equal to 1. So if we take any value satisfy x, that is, we have 1. Values that are less than 1, we have 0, we have -1, -2, -3, and so on. If you try to substitute, now take 0. 0 is actually less than 1, so it is true. And also 1 is included. If we take 1, 1 will be equal to 1. So that's how we do it. Also, we are going to try one more example, and we'll solve that x minus 4 is greater than or equal to 6. So in our case, the first step we can take is to add 4 to both sides. So we end up getting that x is greater than or equal to 6 plus 4, that will be 10. So I'm going to multiply both sides by 3, so that I end up getting x is greater than or equal to that. So it simply means that x is equal to 30. So if we take a value which is equal to 30 and above 30, greater than 30, then it satisfies this equality. Another interesting part, which is very important, we are going to look at multiplication and division by a negative number. And in our case, let us consider two numbers. Take 6 and also let us take 2. The inequality symbol that will satisfy the 2, 6 is greater than. Consider a case whereby we are going to multiply both sides, that is the left hand side and the right hand side, we multiply by minus 2. If we multiply by minus 2, that is multiplied by minus 2 and the other part multiplied by minus 2, then we get minus 12, and here we have minus 4. In our case, minus 12, the correct value or the correct symbol that will replace this, the correct statement will be minus 12 is less than minus 4. Remember, on the number line, minus 12 is to the left of minus 4, so it will be less than minus 4. Also, the same statement, that is 6 is greater than 2. Let us now divide both sides by minus 2. If we divide by minus 2, so that is 6 divided by minus 2, we get minus 3. 2 divided by minus 2, we get minus 1. Still the same case, minus 3 will be less than minus 1. So in general, we can say that the sense of the inequality sign has been reversed when we multiply an inequality by a negative number. And also when we divide by a negative number, the sense or the sign of the inequality is changed or reversed. So generally we can say that multiplication or division of an inequality by a positive number leaves the inequality unchanged, while multiplication or division of an inequality by a negative number reverses the sense of the inequality sign. So this is very important. Always when you divide, know that the sense or the sign of the inequality will always change. And a good example we are going to have is to solve the inequality, that is 1 minus 3x is is less than 4. So the first step we are going to take is to subtract 1 to both sides, and it will give, that is minus 3x is less than 3. Then we divide both sides by negative 3 divided by negative 3. So you'll end up getting x, this will be minus 1. But since we are dividing with a negative number, then the inequality symbol will change. So it will be x is greater than minus 1. If you try to substitute into the original inequality, it should remain true. Take a value of x which is greater than minus 1, and that is 0. Take x is equal to 0, substitute into the original inequality. So what shall we get? That is 1 minus 3 multiplied by 0 to b. So this is already 0. So 1 minus 0, that is 1. And that is true, 1 is less than 4, which is true for this inequality. Minus 7 all over minus 49 is less than or equal to negative 1 over 7. So also we need to solve this inequality. So the first step we are going to do is to multiply both sides by negative 49. So we'll end up getting x minus 7, and the other part will be the 7 1 by 7, that is 7 by minus 41, 1 by minus 41, 49, 1. So that will be x minus 7, and here we have minus 1 times minus, so that is 7. So in this case, multiplied by a negative value, so the inequality symbol will change, and that will be greater than or equal to. Therefore, x will be greater than or equal to 14. So if also you try to substitute, the value will always be true. I'm also going to try one more, and that is solve minus 4 minus 2 over 3x is less than or equal to 0. So the first step we're going to take is to add 4 to both sides. So I will end up getting minus 2 over 3x is less than or equal to 0 plus 4, which is 4. Then I multiply both sides by 3, multiply both sides by 3. So by 3 1 by 3 1. So I get minus 2x is less than or equal to 12. Then I also divide both sides by negative 2. Divide by negative 2. So here I get x. And since I've divided by a negative number, the sense of the inequality symbol will reverse. So it will be greater than or equal to minus 6. Let us prove to see whether it is true. So let us take any value which is greater than minus 6. 0 is a value which we can easily use. So let us take the value x is equal to 0. 0 is greater than minus 6. So let us prove. Take the original equation 1, that is negative 4 minus 2 over 3 x is 0 is less than or equal to 0. Let us see whether it is true. So already this will be 0, so minus 4 is less than 0. And this is true because all values including minus 6 will be true.